All right, now we're going to find slope between 2 points. So on the graph, if we had the graph, we were able to draw that triangle. But if we don't have a graph, we have 2 points, we can still find the slope. So the first thing that we need to do is label our x and y values, our x and y values. Now, for labeling, there are 2 points here. We have our first point here. We have our second point here. The 917 is our first point. The 1325 is our second point. Now, the reason we need to identify which point is which is because now we have to label them as such. Our first point, our x value is x1. Our y value is y1 because they're both part of our first point. Now our second ordered pair, 13 is going to be x2, the x value, and 25, the y value, is going to be y2 because they're part of the second point. So x1 is the x value of the first point, y1 is the y value of the first point, x2 is the x value of the second point, and y2 is the y value of the second point. So once we have these labeled, we're going to plug in our numbers into the slope formula. So let's take a look at our slope formula. M equals y2 minus y1 over x2 minus x1. So let's look at our ordered pairs. We have 917, 1325. y2, that's the y value from our second point. So that's 25. So that's 25. So y2 minus y1. We match up the y values on top. It's really important that we always put our y values on top. Y goes on top. Okay? 25 minus, in this case, y1, that is 17. Okay? On the bottom, x2. So that's the x value from our second point. That's 13. Okay? That's 13. That's 13 minus x1, the x value from our first point. 9. Okay, 13 minus 9. Okay, so we've plugged this in. Honestly, plugging it in is the hard part. Once we have this, we can evaluate and simplify. So that's exactly what we're going to do. Then evaluate and simplify. Okay. I'm going to go ahead and just extend this off to the right. 25 minus 17. 25 minus 17, that is 8. 13 minus 9, that is 4. Okay. So what's simplified is 8 over 4. Simplify, it sure does down to 2 over 1. And that's all. If we know our x values and y values, we can plug them into our slope formula. Okay. I want you to write this next part down really quickly before we move on. Y values go on top. Y values on top. X values on bottom. Okay. Y values go on top. X values go on bottom. Once you have that, then we know that our slope is 2. Our slope is 2. All right, let's try one together. First, we need to label our x and y values. So our first point and our second point. So our x1, the x value of our first point, that's going to be -2. That's x1. y1, that's the y value of our first point. So that's 7, y1. x2 is the x value of our second point. y2 is the y value of our second point. Okay. So let's take a look. We have our slope formula. And go ahead and rewrite the slope formula. M equals y2 minus y1 over x2 minus x1. All right, yeah, just rewrite that because this is something you're going to need to remember. It won't always be written out in front of you. But now let's plug in our values. What is y2? y2 is 22 minus y1. So y1, y value of our first point is 7. So 22 minus 7 over x2, that's the x value of our second point, 3 minus, now be careful here, we have a negative value. So this is still going to be 3 minus, but our x value is negative 2. So 3 minus negative 2. Okay. So this is keep, change. 22 minus 7, that is 15. 3 plus 2. It was 3 minus negative 2. That becomes 3 plus 2 over 5. Does 15 over 5 reduce? Yes, it does. Down to 3 over 1. M equals 3. M equals 3. Let's again do one more together. Then I'll have you do the last 3 on your own. So we have negative 17, 20, 6, 15. Let's label our x and y values. So we have our first point, we have our second point, we have x1 and y1, the x and y value of our first point, x2 and y2, the x and y value of our second point. And so let's refer back to the slope formula, y2 minus y1 over x2 minus x1. This is 15 minus 20 over 6 minus, again, that negative shows up again, negative 17. Okay, so 15 minus 20 over 6 minus negative 17. Let's see, 15 minus 20, that is negative 5 over 6 minus negative 17, keep, change. 6 plus 17, that is 23. That is 23. Okay, so our M is negative 5 over 23. Go ahead and work on the next 3 on your own. All right, so our last way to find slope today, it is, we're actually not going to start in the box quite yet. What we're going to do instead is we're going to start with this table. All right, now the reason we're starting with the table here is because we need to identify what's actually going on here. We see 0, 2, 4, 6, 5, 4, 3, 2. What we're actually saying here is that we have ordered pairs. Okay, we have ordered pairs of 0, 5, 2, 4, 4, 3, and 6, 2. What I mean by that is that we have these coordinate points of 0, 5, 2, 4, 4, 3, and 6, 2. Okay. What we're really doing is we're finding the slope between these ordered pairs, just like we did on the previous page. Just like we did on the previous page. So what that means is we can actually use the same method. So let's go ahead back to our box now. First, we're going to label, oops, misspelled label, sorry guys, L-A-B-E-L, L-A-B-E-L. So we need to label 2 sets of coordinates. We can pick any 2 sets of coordinates, any 2 ordered pairs from this table. It doesn't matter which ones we pick. I'm going to pick 1, 4, and 3, 10. Okay, So our x values are going to get x1, x2, y1, y2. This is our first ordered pair and our second ordered pair. Okay. If it helps you to pull these out, go ahead and do so. Let's say we have 1, 4, and 3, 10, x1, y1, x2, y2. If that helps you, so we can go back and kind of look at it in the same way we did with our ordered pairs, go ahead and do so. All right. But once we have these, we're going to plug them into our slope formula. Slope formula. Okay. So y2, that's going to be 10 minus y1 because y is stay on top. So 10 minus 4 over x2, that's 3, minus x1, that's 1. Once we have it plugged in, same process, evaluate, and simplify. So 10 minus 4, that is 6 over 2. 3 minus 1 is 2. Does that simplify? It sure does. That simplifies down to 3. Simplifies down to 3. Let's try another one. Again, it doesn't matter which ones we use. I'm going to go ahead and pick this first one. We'll do some practice with negative numbers. And let's use the last one. They don't even need to be next to each other. So x1 for -2, y1 for -3, x2 for 2, y2 for 3. So let's plug it into our slope formula. y1 minus y2 over, y2 minus y1 over x2 minus x1. So we have 13, that's y2, minus y1 is -3, so minus -3 over 2 minus -2 minus -2. So 13 minus -3 over 2 minus -2. That gives us, keep change on top, 13 plus 3, that's 16, over 2, keep change plus 4, plus 2, that gives us 4. Let's ask ourselves, is 16 over 4, does that reduce? Yes, that reduces down to 4 over 1, or m equals 4. Now these two examples ended up being whole numbers, but just like before, we could have fractions as our slope. We could definitely have fractions as our slope. So we'll finish the one that we started together here. Let's use 0, 5, and 4, 3. We have x1 as 0, y1 as 5, x2 as 4, y2 as 3. We'll plug it into our slope formula. That is 3 minus 5 over 4 minus 0. Okay, 4 minus 0. So 3 minus 5, that is -2 over 4 minus 0. Well, that just remains 4. Does -2 over 4 reduce? Yes. M equals -1/2. Go ahead and work on the next two on your own.